Let's take a look at example 3. In example 3, they say that a particle moves along a coordinate axis in such a way that its position at time, I'm missing a letter T here. At time T is given by, and then I have this S of T is equal to 2 sine T minus T. And they give me this, coordinate, this range of values. So from 0 to 2 pi, that's the entire circle. Okay. And what we want to know is, we want to know at what time is the particle at rest. So this at rest seems important. So I want to ask you guys a question to try to help us solve this problem. We know that there's a relationship between the position function, the velocity function, and the acceleration function, right? We know that that relationship exists. And what's the relationship? They're related by their derivatives. So if you differentiate with respect to t, the position with respect to t, get the velocity. If you differentiate the velocity with respect to t, you would get the acceleration. So I'm writing it with the differentiation operator on the left over here. But you could have also said, oh, v of t is just s prime of t, and a of t is s double prime of t. Does that make sense to everybody? This is kind of what your quiz was about. Some of you only did the first derivative. You got to do 2 derivatives. Okay. For the acceleration, I mean. Now, here's my question for you. When we talk about being at rest, my question is that a position thing, a velocity thing, or an acceleration thing? What do you think? Anyone? Position, velocity, or acceleration? What does at rest refer to?
Position?
Position?
Yeah.
Position would be like, where am I at rest? Right? Position is like, where are you? Velocity is how fast are you moving? So when I think of at rest, I think that's a velocity thing, because it's like, are we moving or are we not moving? If we're moving, we have a non-zero velocity. But if we're not moving, oh, that's going to be a velocity. That's going to be at rest. So when I see this word at rest to me means the velocity is equal to 0. Okay. I saw that Mario, took a stab at saying maybe it's the acceleration. Acceleration is how quickly the velocity is changing. So that's something that's a little bit different. If the acceleration is equal to 0, that means that the velocity is not changing at all, which means that your object is moving at a very steady speed. It's not speeding up or slowing down. If it speeds up, then that's non-zero acceleration. If it slows down, then it's non-zero acceleration. Okay. So really our goal is to figure out when this velocity is equal to 0. So to that end, I'm going to write down my position function. I'm going to calculate the velocity by taking its derivative. And the 2 stays there. The derivative of sine is its cousin, cosine. It's not negative because sine does not have a co in front of it. And the derivative of negative t is just -1. So now what I'm going to do is I'm going to set it equal to 0. So 0 is equal to, or let me do it this way. 2 cosine t is -1 is equal to 0. And this is, since we are talking about at rest, means not moving. Then when I solve this, I'm going to get I can add 1 to both sides. I get cosine of t is equal to 2 cosine of t is equal to 1. And divide both sides by 2, I get cosine of t is equal to 1/2. So I got to solve this. I gotta ask myself, what t between, which is in the set from 0 to 2 pi, which is this unit circle, have cosine of t equal to 1/2. Okay. So there's many ways that you could do this, but I guess I'm going to emphasize the unit circle approach right now. So let me so here is our unit circle. I had kind of shown you that you could just find the unit circle online pretty easily. But the part I want to emphasize for you guys is that the unit circle has all these different angles. And then the red parts are all the different points associated with the unit circle. And cosine is going to be the x values. So if you were to use the unit circle approach to solve when is cosine of x equal to 1/2, you just want to know what angles have an x value equal to 1/2. And when I come over here, I hope you guys can see that this angle at pi over 3 has a 1/2 for the x value. And this 5 pi over 3 also has a 1/2 for the x value. So if I were to go back to my original worksheet, this is basically saying that t is equal to pi over 3 and 5 pi over 3. And I'm going to put using the unit circle. X is equal to 1/2. Sorry, theta is equal to 1/2. Theta is the angle, so I don't know if I should put theta there, if I should put t there. T is better. Or I'm sorry, oh man, that was a, sorry, let me say this better. Cosine of theta is equal to 1/2 is the same thing as saying x is equal to 1/2. So we're looking for the x values that are 1/2. Okay. So that's how I get these two angles.
Professor?
Yes.
Is that the time, like we answer the time using a P? Or we gotta simplify again by 3.50 3.14 per 3?
I'm not sure what you're asking me, but our answers will always be in radians.
Oh,
I know you guys are used to like punching things into your calculator, but I kind of need you to know, like, you have to get used to all these strange looking numbers like rad 3 over 2, 1/2, 1 over rad 2, stuff like that. You have to be able to work with these radians in calculus. Does that make sense?
Can we simplify the answer, become a real number without using the pi? So if for example,
What I'm saying is I want the pi. Like, we want the pi in there. We don't want these crazy decimal answers.
Okay.
The pi answer is more meaningful to us. Yeah.
Thank you.
Okay, no problem.